All right, class, in this video we're going to talk about Euler's method, which is a means of approximating a solution to a differential equation. We're not going to actually find the exact values or whatever exact solution, but we're going to approximate the solution. So we'll start with this abstractly. So dy dx equals f of xy. That means there's x's and y's on the right hand side. And we have some kind of initial condition. We'll say y of x0 equals y0. All right, so there's going to be a couple of things we need. And they can ask it in a couple different ways. So they can tell us the number of steps and an interval. Okay? That's not the only kind of way they can give it to us. They can tell us the number of steps and the step size. And then you can figure out what the endpoint is that you're looking for. Okay, so for all of that, what's the deal here? So the deal is we're going to need to know what delta x is, and as in everything we've ever done, that's b minus a over n. So the interval would give you the a and the b, and then n would give you the number of steps. Or we could start with the step size, which would be delta x, and tell you you'd already know the starting point, and you know the number of steps, so you could figure out the endpoint. Okay, so here's how it works. So let me just draw a picture here. Okay, so the idea is that if we had the actual solution to the differential equation, maybe it looks something like this. Okay, and so we would have our initial condition. So x0, and we're going to put that point right there. So x0 and y0. So this would be a point that's actually on the actual solution, because in an IVP, that's the deal. That point has to be on the curve. And so we would basically use our step size to move to the next x value, which would be maybe x1. And how are we approximating the solution? We're basically using a piece of tangent line. So we'd find the tangent line at x0, y0, and we would graph maybe, or think about graphing, that much of it. And then we would end up at, that point would be x1, y1, and then we'd just redo that process again. So we'd find the tangent line at x1, y1, and we'd know the endpoint for that, and we would have this x2, y2, and so forth and so on. Okay? So the things that you need to know about Euler's method in terms of what they're going to ask you on the AP exam. Remember they said calculator is not necessary. So what I've drawn here is probably the most you're ever going to have to do on this or any other AP exam. They figure if you know how to do 2 iterations by hand, you can do 1,000 iterations on the computer. And really, if you were using Euler's method to actually try to approximate something, you really wouldn't use 2. You'd use 100 or 1,000 iterations, and you would do it with some kind of technology, like a calculator or programming or something like Maple, or even an Excel spreadsheet. Spreadsheets actually work really well here. All right, so there's a couple of formulas that go with it, and I'll say here, you don't really know how what the formulas are. You need to know how to get them, or what their concept is behind it. Okay, so I'm going to say here that would be tangent line 1, and that would be tangent line 2. So we need the equation of tangent line 1. Okay, so that's going to be the slope, which would be dy dx. Now up here we have dy dx in terms of f of xy, and we know an x and a y. So we would substitute x0 and y0 into that right-hand side, and that would be the slope of that tangent line. Okay, and then that would be multiplied times x minus x0 plus y0. So all I've done there is that's the equation of the tangent line at x0, y0. Okay, now notice that x1 is x0 plus delta x. Okay, so to get the next endpoint, so to get this endpoint here that I'm trying to figure out, I need the y value. I already know the x value. I need the y value. So I just plug this x value into this equation to get the y value. So y tan 1 of x1, so that's going to be f of x0, y0. Remember, that's a constant, not a function. And then you'd be plugging x1 here. So x1 is x0 plus delta x minus x0. So that times delta x plus y0, and that would be y1. Okay, so in essence, you're going to be generating these things based on two different iterative formulas. So let me show you what those are. And iterative just means repeated. Okay, so x sub n plus 1. So how do I get the next x from the previous x? I do xn plus delta x. So that's the easy one. And then how do I get the next y value? Basically, I plug the x value up here into the tangent line for the previous y value. And I'm going to write it like this. So this would be yn plus f of xn yn times delta x. Okay, so that's going to conclude, this is just the theoretical part of it. So that'll conclude this part. I'm going to do two examples in basically two different ways. So it's actually the same example in two different ways. All right, so that's the next video. Bye.